Hello, phenomenal ladies and gentlemen. It's Matthew Farrow here again, and welcome back to my space. This video is the next in the virtual playlist where we're talking about the questions from the problem sets in a virtual assessment. And this is the third of the questions on the derivative part of the questions. And here we're told to take the derivative to differentiate the function y plus sine xy plus e to the x cubed. And this is what we call an implicitly defined function. So it means we are about to look at implicit differentiation. So this question has defined for us as no equation sign. So it is not an equation. But of course, we can represent it by a letter. So let f be equal to y plus sine xy plus e to the x cubed. And the assumption here is that y is a function of x. So y depends on x. So how do we take the derivative of a function that is not defined as an explicit function of y as a function of x? So what we do is to differentiate implicitly. So what does this mean? So we are interested in getting the f dx. Yeah, we want to take the derivative of this function. That is, we want to do d dx of y plus sine xy plus e to the power of x cubed. And like we know the sum rule, the derivative of a sum is the sum of the derivatives. So this means we are going to get the y dx plus d dx of sine xy plus d dx of e to the power of x cubed. And then the y dx is settled itself, so the y dx. And what is the derivative of sine xy? That is a chain rule. You have the main outer function to be sine, and you have the inner function to be x times y. So, and what does the chain rule says? The chain rule says the derivative of a composition is the derivative of the outer function evaluated at the inner function times the derivative of the inner function. That is, if y equals to f of g of x, f is the outer function and g is the inner function, then the y dx is equal to f prime, derivative of the outer one, evaluated at g of x, times the derivative of the inner function. In other words, we also know the chain rule as the y du times du dx, where u is the inner function. So in this case, the outer function is sine. So the derivative of the outer function here will be cosine. So we evaluate it at the inner function xy. Then times the derivative of the inner function. So the inner function is the product of x and y, because y is a function of x. So we have to use the product rule here. Now what does the product rule says? If we have y equals to f of x times g of x, then the y dx is equal to f prime of x times g of x plus f of x times g prime of x. That's the product rule. In other words, is equal to u dv dx plus v du dx. So if we use that on xy, where this is our u and this is our v, we are going to have u dv dx plus v du dx. The u dx means the differentiation of x, and that is 1. So that's the derivative of sine xy. Then the last one, the derivative of e to the power of x cubed. So that is also another chain rule where the inner function is x cubed. And we know that the outer function is e to the power of x. So the derivative of e to the power of x cubed will just be e to the power of x cubed. That's the derivative of the outer function times the derivative of the inner function, 3x squared. In general, if y equals to e to the power of any function of x, then its derivative will be equal to e to the power of f of x times f prime of x. So f of x here in this case is x cubed. So its derivative is 3x squared. That's why we have this information. And that's basically what we need to do here, because that means the f dx, derivative of the given expression, is equal to the y dx plus cos xy times x dy dx plus y plus 3x squared e to the power of x cubed. That will be the final answer. Anyway, if the question was given as an equation, then we will be asked to find dy dx itself. It's different from giving you a function that is not an equation and asking you to find the derivative. So if the instruction is find the differentiation or derivative. So if the question was just differentiate the function sine x squared, there is no dy dx here because there is no y. What would we just say is that the differentiation of sine x squared is 2x cos x squared. But if you're told given y equals to sine x squared, find its derivative, then we can say that dy dx is equal to 2x cos x squared. Why am I saying this? It's because the question is a bit different if it were to be find dy dx if y plus sine xy plus e to the power of x cubed is equal to something, let's say 3. So if this is the question, and we are told to find dy dx, if y and blah blah blah, then find dy dx. That's a different ball game. In this case, we take the derivative of both sides. So we have derivative of y plus sine xy plus e to the power of x cubed is equal to the derivative of 3. So we have already found the derivative of the left hand side. That is the answer we got here. This one here. Copy, paste. And the derivative of the right hand side, since 3 is just a constant, is 0. So from here, we can now make dy dx subject of the formula. It's very simple because we just need to isolate dy dx. Put every other thing on the other side. So here we have the y dx plus x cos xy dy dx plus y cos xy plus 3x squared exponential x cubed equals to 0. So I can transfer those guys that do not have the y dx to the other side and pull out the y dx to isolate it. So that would be, so the y dx is common here and here. So if I pull it out, I will have the y dx 1 plus x cos xy on this side. And on the other side, I'm going to have negative of y cos xy plus 3x squared exponential x cubed. Then what do I need to do to find the final answer dy dx? I just divide both sides by 1 plus x cos xy. So if we divide both sides by 1 plus x cos xy, I'm going to get the y dx is equal to negative of y cos xy plus 3x squared e to the power of x cubed all over 1 plus x cos xy. And this will be the answer to this question. So you should notice the difference between the two questions. Okay, the first question is just differentiate this function. The second one is you're given an equation, given y plus sine xy plus e to the x cubed is equals to 3. Find the y dx. There is already an equation here, so we can find the y dx. But here, there is no equation, so we shouldn't manufacture one ourselves. The only thing we can do is to represent this function with maybe a letter like we did here, f, and do the f dx. Okay, so but we cannot find the y dx when it is not an equation. That is not how it works with implicit functions. And with that, we've come to the end of this video, which is on implicit differentiation. If you have any questions, observation, or remarks, kindly share it in the comment section and we can discuss about it. But until then, until our next video, continue to learn mathematics and have fun with mathematics. Bye.